Welcome to EDU World Space.
In this question, we have a block with mass of 2 kilograms resting on an inclined slope which has an incline of 37 degrees. There is a spring fixed at the bottom of this incline. When the block is released, it slides down the slope and compresses the spring by a distance of 0.2 meters. What we want to find is the coefficient of friction between this block and the slope, and we want to find the spring constant of the spring. So in order to do the first part of this question, we can apply the work energy principle for the downward motion of the body. We know that initially all of its energy is stored as gravitational potential energy, and if we take the bottom point to have zero gravitational potential energy, we know that at this point all of the energy is elastic potential energy. However, some energy has been lost between the start and final position due to the work done against friction. So what we can say is that mg, and we must resolve this component parallel to the slope. So as we can see here, this angle is equal to 37 as well. So this component is sine 37. So this is the force, but we must multiply by the distance, which is 4.8 times 0.2 to obtain the work done. And this must be equal to the work done against friction, where the frictional force is given by mu r. So again, multiplied by the distance, we've got 5 mu r plus the elastic potential energy due to the compression of the spring, which is given by 1/2 kx squared. Now we know that the mass is m, we know that the compression is 0.2, we know what sine 37 is, as we've calculated it from here, and we know the reaction force must be equal to the perpendicular component of the weight, so mg cos 37. So by plugging all of these into this expression, we get an expression that says that 80 mu plus 0.02k is equal to 60. So this is our first expression that we're going to need to use to solve for mu, so the coefficient of friction. So the second step is to apply the same work energy principle, however now for the upwards motion of the body. So again, we know that the initial elastic potential energy must be equal to the final gravitational potential energy, subtracting the work done due to friction. So what we can say is that 1/2 kx squared is equal to 1, because now it's travelled 1 meter up the slope, so that's the distance, times mg sine 37 minus, as this work is done due to friction is lost energy, so minus mu r. So again, plugging in what we know, we've got an expression that says that minus 12 minus 16 mu plus 0.02k is equal to 0. So this is our second expression. And now, by adding equation 1 and equation 2, we get that 96 mu is equal to 48, and therefore mu is equal to 0.5, which is our answer for the coefficient of friction. Now all we need to do is plug this value into this expression to obtain a value for the force constant, as then the only unknown is k. So doing this, we get that the spring constant, so k, is equal to 1000 newtons per meter. So we have a coefficient of friction of 0.5 and a spring constant of 1000 newtons per meter.